In this video, we're going to go over the power rule for derivatives. This rule allows us to take the derivative of a function containing an exponent. Up in the right-hand corner, we have the formula for the power rule. Basically, we need to get the function into this form, x to the power of n, and we can see that our problem statement is already in this form, so we can jump right in and apply this formula. So what I like to do is pull out the coefficient, and we just have to bring this exponent down in front of the x, and then subtract 1 from the exponent itself. I like to write it out like this to help me keep everything in order. So we have 4 times 2x to the 2 minus 1, which equals 8x, and that's our answer. When we have a function containing multiple terms with exponents, we can treat each term as its own mini function and take the derivative of each one at a time. However, the first step we need to do is get all these terms in the form of x to the power of n. Starting with the first term, we have 1 over root x, which as we know is just the same as 1 over x to the power of a half. And to get this term in the numerator instead of the denominator, we can simply change the sign of the exponent. Similarly, in the second term, we have 3 over x, which is the same as 3x to the negative 1. And the third term, 4 over x squared, is just the same as 4x to the negative 2. This will come in handy when we go to take the derivative of each of these. So this can be rewritten as taking the derivative of x to the negative 1/2 power minus 3x to the negative 1 plus 4x to the negative 2 power. And to take the derivative of all these terms, we can implement the same notation that makes it easier as before, where we take the exponent as the coefficient and then subtract 1 from the exponent. So we can see that this can be rewritten as negative 1/2 x to the power of negative 3 over 2 minus 3 times negative 1 x to the negative 2 plus 4 times negative 2 x to the negative 3. And then we can simplify that further as negative 1/2 x to the negative 3 over 2 plus 3x to the negative 2 minus 8x to the negative 3. And we can leave our answer just like this. We could also change these negative exponents to become the denominator of the fraction, but not necessary for this topic. And this is just to illustrate that we can use this method to make it easier to take the derivative of terms. So similar to the previous problem, we see that we have a radical in the denominator of our function, and our goal as the first step is to always try and transform the function into the form x to the power of n. So how can we do that for this one? So just like the other two problems, we need to start out by making sure that our function that's given matches the form x to the power of n. And in this case, it doesn't quite yet, so we're going to have to transform this radical into its exponent form. So something that I do to remember how to properly transform radicals into their exponent form is to simply remember this example, that if we had a regular radical of x, that's equal to x to the power of 1/2, meaning that we take the number inside the radical and we put it on the bottom of the exponent fraction. So that just helps us when we have weird radicals like the 5th root and we have an exponent underneath the root. So in remembering that the root of this radical needs to go on the bottom of the exponent, we can rewrite this function as negative 1 over 2 times x to the 3/5. But this still isn't in the form of x to the power of n. We need to get x to the n in the numerator. So similarly to the last problem, we just changed the sign of the exponent in the denominator. And this is now in the form where we can apply our power rule. So rewriting this all together, we're taking the derivative of negative 1/2 x to the power of negative 3/5. And to utilize our trick from before, we remember we have to take the exponent and put it down as a coefficient and then subtract 1 from the exponent itself. So simplifying this, we get negative 1/2 times negative 3/5 times x to the power of negative 8/5. And then finally, we end up with the answer of 3/10 x to the negative 8/5. So just some key takeaways from what we learned today. As long as we remember that we need to transform the function into the form x to the power of n, we'll be fine in plugging in this formula, and we shouldn't have any problems on the exam with the power rule. So I recommend that we remember this simple rule where the square root of x equals x to the power of 1/2, and utilize these tools that we can transform radicals into exponents and exponents in the denominator to exponents in the numerator. Once we do these two things, we shouldn't have any trouble solving these problems. So that's the end of this video. I hope that was helpful and that you have one less problem to worry about on your exam. If you like this video, please like and subscribe so I can continue helping you guys crush your calc exams. Good luck, everybody, and see you next time.